All right. This is the Algebra 1 new Unit 7 Lesson 4 video over rational exponents and radical expressions. So we talk about a rational exponent. We're talking about exponents like so far we've kind of had things like, for instance, x squared, which means x times x. Multiply x times itself twice. Or we've had a to the fourth. It's a times a times a times a. So what does it mean, for instance, when we have a rational exponent, which in other words means something like this, a to the 2/3. So that doesn't quite fit the pattern that we did up here with our basic exponents. We know how to deal with that number when it's a whole number because we just multiply x times itself twice or a times itself 4 times. Well, what do I do with a to the 2/3? Well, there is an explanation for what this actually means. And what a rational exponent actually means is that we are now dealing with roots. And roots are really just the opposite of exponents. So when we have this expression a to the 2/3, it actually means the following. It means a squared, but underneath what we call a third root or a cube root. And so two things are happening. First of all, a is being multiplied times itself twice, but also we're trying to find the number that times itself 3 times gives me that number. So there's a lot going on in these types of expressions. So I want to kind of point out one thing from the lesson, which is this rational exponents property pretty much explains what I just showed you here and explains how you get from a rational exponent into a root. So for instance, just as another example, if I had the square root of b to the 7th power, that could be rewritten as b to the 7 over 2. Because it is a power of 7 and a root of 2. So in general, the top number is the power and the bottom number is the root. So that's kind of the key piece of information here. And they go through some examples here to kind of explain. So a radical symbol is, like I said, the opposite of a root. So a radical, so whereas x squared tells me to do x times x, the square root of x asks me the question, what times what itself gives me x? So the square root of x is saying, like, what can I multiply times itself to get x? To use an answer of something that we know, for instance, the square root of 9, ask the question, what times what gives me 9? And so the answer is 3. So the square root of 9 is equal to 3 because 3 times 3 equals 9. So that's why 3 would be the answer. So that's what radicals do. A radical symbol is anytime you have this kind of checkmark box symbol. Underneath the radical is what we call the radicand. And that's kind of just some vocabulary you're going to have. But in general, what's happening is we are working to try to find things that can be simplified in the way that I simplified this in square root of 9. In other words, we're trying to find things that are, in a word, perfect square roots. Now, there is a list on table 4.1 of what we call common powers. And what this is saying is, for instance, that 4 to the 2nd power is 16. So 4 squared would be 16. Let's write that down here. So this would be like 4 squared would be 16. 4 to the 5th power, that goes all the way over to here, would be 1024. And so this is telling you to find the number and its power, and then line it up, and that shows you what that number would be. So 4 to the 5th power would be x equals 4 to the 5th power gives me 1024. The reason they give you this table is that you're going to need this as you go to work out these expressions. So basically what we're going to be doing is I'm going to go through with some examples and show you what it means to simplify a radical expression. Okay, so I'm going to jump over here. I have some examples that I've already made. And I'm going to talk you through what you're looking to do. So the main property that we're going to use here is the idea that I can take a radical like this, and if I can find numbers that multiply to make this number on the inside, I can make this into smaller parts. So for instance, we know that 8 and 7 multiply to make 56. So we also know then that the square root of 8 times the square root of 7 equals 56. Same thing goes for 8. I know that 8 is 4 times 2. So then I know that the square root of 56 is the same as the square root of 4 times the square root of 7 times the square root of 2. And then this is where you need to use our little chart. I see right here that the number 4 is on my chart. It's right here. 4 is 2 squared. And since I have a square root, and it says the square root of 4, that means the square root of 4 is 2. And so this can be transformed into a 2. And then the other numbers do not simplify to make square roots. The easiest way to check this is just to come over here and say, okay, well, is the square root of 7 a perfect root? Square root of 7? No, it's not. It's 2.64. So I need to know when I'm looking at a perfect square root. So the square root of 4 is 2. And then 2 times 7 is 14. And so this would be 2 times the square root of 14. And so I want to break this down into perfect square roots and then simplify as I can. So like in number 2, 32, it can be broken down into 16 and 2. And y is just y squared. So I've broken this expression down into parts. And then if I go through them, I notice that the square root of 16 is 4. And I know the square root of 2 cannot simplify. And then y squared square root. This is where this kind of comes into important play. If I rewrite this expression as a fractional exponent, I have a 2 and an imaginary 2 here. It becomes 2 over 2, which becomes y to the first power. And then again, I can rewrite this to be 4y times the square root of 2. And then we're done. So we're just going to keep going and work through different examples looking for these perfect square roots. So I'm going to break this up. It's going to be the square root of 25. It's going to be square root of a squared and another a squared, because a squared times a squared is a to the 4th. Sorry about that. B is going to be b squared 3 times, because b squared, b squared, b squared, and then of course c squared is by itself. So notice each of these is going to be able to be simplified. 25 becomes 5, a squared becomes a squared becomes a, b squared becomes b squared becomes b squared becomes b, and c squared becomes c. And then if I put that all together, I get 5. I have 2 a's, so that's a squared. I have 3 b's, so that's b to the 3rd, and I have 1 c, which makes a c. So this is what you're going to do. You want to expand and then simplify. Now, number 4 introduces fractions, but you don't need to let this throw you off, because I can still do this on either side of the fraction. So I'm going to break this up into 2 parts, 8, a4, b6, and then on the bottom it's going to be 49, a6, b squared. And then I'm going to break each of those up into different parts. So we'll go through. We're going to have the square root of 4 times the square root of 2 times the square root of a squared times the square root of a squared, because there are 4. Then the same thing with b. I'm going to have 3 of them. B squared, b squared, b squared. Then we have the square root of 49, which is a perfect square root. And if you look over here on your chart, you'll see it 7 squared. So that's great. And we always want to look under whatever number we're using. So if we have square root like we do here, we look under the x2 column, which would be this first column here. So these are the numbers I'm trying to look for. 49 comes out. Then we have a 3 times because a2, a2, a2 makes a6. And then b2, I just have one of them. So I know this is a lot. But if I run over here and I start simplifying things, I get, for the first one, square root of 4 is 2. That square root of 2 is going to stay, so that one's done. We're going to go A, 1, 2 of them. I'm going to have 3 B's. And then this square root of 2 is just going to come down here. On the bottom, the square root of 49 is 7. A, that's 3 A's. And then a B. And then really, if I want to go to the full extent, I want to simplify by canceling out some A's. There are 2 A's on top and 3 on bottom, so those 2 go away, and this goes down to 1. There are 3 B's on top and 1 on bottom. So then we go down to 2b squared, square root of 2, over 7a to the first, or just 7a, and we're done. That might be the most complicated problem in this lesson, but just kind of watch that slowly and kind of listen to the process as I kind of talk through it. Next one, we have the third power. So this tells me that I want to look in this column right here. And I'll see right away, looking at the 2, that I have 125 and 512 in my list. So 512, if we look over here, is 8 to the third power. So really this means that this can be broken up into the cube root of 512 over the cube root of 125. And then 512 cube root is on my chart. It is 8. So I put an 8. It just simplifies completely to 8. And then the cube root of 125 simplifies to 5. And so that's literally my answer. Now, the other thing you could do, you can hop over here to Desmos, and we can do this in our calculator. So we can do see this in root, we can do 3 and then click the in root, and sorry about that, third root of 512 divided by 125, and then we can convert that into a fraction and we see it is 8 over 5. But knowing your roots is probably the easiest way to do this. All right, number 6, looking here, we have the 9 to the negative 1/2. Okay, so let's do this first. We know that when we have a negative, we actually mean that this is being flipped to the bottom. So this should be, let me rewrite that again. This should be negative. This should be 1 over 9 to the 1/2 power. And once we get that, we know that this can be converted into 1 over the square root of 9, because this is a root of 2 and this is a power of 1. We don't actually need to write those because we assume a 1 and a 2 when we do this normally. So this is going to be the square root of 9. We know the square root of 9 is 3, and so it's 1/3. Okay. Number 7. A little bit more complicated. We're going to break this up into parts. We are going to split this thing up into the cube root of 6a to the 4th, bc to the 6th, all over the cube root of negative 27. We know that we need to continue to break this up completely until it's completely broken up. So we have the cube root of 6 times the cube root of a to the 3rd times the cube root of a. So I broke up a to the 4th into 2 so that I would have 1 with a 3. I have the cube root of b, and then I have 2 cube root of c to the 3rd. And then on the bottom, I still have the cube root of negative 27. So I go through and see what there is that I can simplify. I can't simplify this, but this first a can be made into an a. This cannot be simplified. This cannot be simplified. These can both be simplified into c squared. And then since 27 is a perfect root, it simplifies to make negative 3. And then everything that's left in the top is still there, 6ab. And actually, that is an acceptable answer, but we actually want to bring this negative out front and make it a c squared 6ab all over 3, and that would be the best final answer there. Number 8. Again, we have a negative root. So I need to do some work here. I need to change this to be 1 over 125 to the 2/3 power. This can be rewritten as 125 squared with a cube root of 3. We know that the cube root of 125 is 5. So this can be rewritten as 5 squared, which is 1 over 25. And that's it right there. And I also can type that denominator into the calculator here. So let's see what that would look like. So if I did the cube root of 125 squared, I get 25. And so that's why we end up with 1 over 25. I'm going to grab this guy. Oops. I'm going to grab this guy, move him down here. Oh, there's not much to say about this one. Any number raised to a 0 power, we should know this from the last lesson, is 1. That is the answer. It doesn't matter what it is. Anything to the 0 power is 1. Number 10 introduces a kind of slightly different way of thinking about this, but we know that we can distribute exponents. So we're going to distribute that 4. So this first term becomes m to the 3 over 2 times 4, and n to the 1/2 times 4. And then this p should be just simplified to a p because it should be p to the 1 because this is the square root of 2. So that automatically simplifies. Now we just need to multiply these numbers. 3 over 2 times 4. We'll just hop over here. 3 over 2 times 4 is 6. So that becomes m to the 6th. N to the 1/2. So 1/2 times 4. Oops, made a mistake there. Times 4 is 2. So that becomes n times 2 and then p to the first, or just p. Looking at number 11, that negative is just going to stay out there, but I'm going to break this 40 down into parts. Draw a dividing line here. So 40 is going to be 4 and 10. There's a negative out there still. That's okay. We'll just leave that alone for now. Square root of 4 is 2. 10 can be broken down into 5 and 2, but neither of those are square roots. So this just stays as 10, and it's negative 2 times the square root of 10. So there's a lot of new kind of concepts or new kind of like ways of working things out in this lesson. But please utilize these example problems. And I will also post a link to another set of examples that I did for another video. But that is it for this lesson video for Algebra 1, Unit 7, New Unit 7, Lesson 4.